Hello everyone, welcome to this next question on abstract algebra. This question is again from June 2011 consisting of 4.75 marks. The question is, if I1 be the ideal generated by x square plus 1 and I2 be the ideal generated by x cube minus x square plus x minus 1 in Qx, right? Then they are saying R1 given by this and R2 given by this are defined like these, then which among these four is correct, right? So let us see few results that we would need in order to check whether this R1 and R2 they are fields or integral domains or not, right? So in order to check this quotient ring, they are field or not, what we can do, we have this result. The result says that quotient ring of this form forms a field whenever this ideal generated by Px is maximal and the polynomial is irreducible. This polynomial is irreducible polynomial over f. So in order to check whether R1 and R2 form field or not, we can check that the polynomial. Firstly, we'll check for I1. The I1 is generated by this polynomial x square plus 1, right? Now this polynomial, this is irreducible polynomial in Qx. Why? It is because we can only factor this polynomial as x minus iota and x plus iota, where this iota, the coefficients of these two polynomials, they do not belong to the field of rationals, right? So that means this polynomial cannot be further factorized into linear factors such in Q, right? Therefore this polynomial is irreducible in Qx. So this thing is true. Now because this polynomial is irreducible in Qx, then the ideal generated by this polynomial is maximal ideal, right? This is a maximal ideal, and this R1 would be a field. So according to this result, R1 would be a field because the corresponding polynomial is irreducible over f. So according to this, we would say yes, R1 is a field, so this option may be correct, right? Maybe this option may be correct. So let us go for checking the second polynomial for I2. So I2 is generated by this polynomial x cube minus x square plus x minus 1. Now this polynomial, if you see it closely, you can create the factors for this polynomial like this. So it could be written as x square plus 1 and x minus 1, where all the coefficients of these two factors, they are in Q, right? So this belongs to Q. Therefore, we have factorized this polynomial into two factors, right? Therefore, this polynomial is reducible in Qx. Therefore, the ideal generated by this, that is not maximal, and if it is not maximal, the corresponding R2, that is not a field according to this result, right? So this is not a field. So accordingly, option B is correct, option A is incorrect. Now, in order to check whether R1 and R2, they are integral domain or not, we can have this result that every field is an integral domain. So if it is a field, it is an integral domain. What is the definition of field and how a field and integral domain differ from each other? So basically, field is an integral domain with one extra property, that is it has multiplicative inverses also. So you can clearly see if something is field, so that would surely be integral domain because it has now one extra property of this inverses. So they are saying every field is an integral domain, but the converse is not true. So accordingly, we have seen that R1 is field. So this implies R1 is an integral domain, right? So according to this result, we can have this. So accordingly, in option D, they are saying R1 is not an integral domain, so this option is incorrect. And based on R1, R1 is an integral domain. This part is true. Now, what can you say about R2? Now, you may have seen that this result does the converse for this result, that every field is an integral domain, does not hold. So we may look at another results also for integral domain. They are one such result is, if R is commutative ring with unity, then I is prime ideal if and only if R upon I is an integral domain. And if R is commutative ring with unity, then every maximal ideal is also a prime ideal. So in this case, the ideal I2, that was not maximal. Why? Because the corresponding polynomial comes out to be reducible. But we cannot apply this result also. Why? Because the converse for this result is not true. We say the maximal is ideal, but it is not prime ideal. So from here, I cannot comment anything about R2 from here. If any one of you found a suitable reason for that, please do comment in the comments, right? So accordingly, depending on this R1, I would mark C as the correct option. So according to me, this option B and C are correct without any comment on R2. Well, that is it for this video. If you have any suggestions, please do write in the comments. Thank you for watching.